And here we go. Fall 2019, test one. It's not test one. I think I made that typo all the time here. Test two. Okay. Test two. All day. Test two. Okay, got a blank page. How do we even start one of these problems? Well, we start by crossing off our spectators. And there's a spectator. And then we connect our partners. The partner pair that is already there. Okay. Partner pair that is already there is here. Which one of those has one more proton? The one on the right. The one with one more proton is the acid. If you put a 50 here, you're not thinking about the bonding in this molecule. This molecule is ethene, which is an alkene. Our second weakest acid on our table. Then the other pair must be this pair. And because ethene was an acid, this must be its conjugate base. -31. I would like to point out right now that if on the test you just wrote pKb equals -31, I would give you full credit. But if you knew how to do this problem and only wrote down by mistake pKb equals -21 because you did a math error, you get nothing. If you wrote pKb equals 14 minus 45 equals -21, you get half your points back. So it's a half point for the whole thing anyway. So you get a quarter point instead of 0 if you show your work. No partial credit for no work shown. Now the question is, how do we know this is an acid or a base? In this equilibrium, it has to be an acid because bases don't react with bases. Now the question is, which of the pKa's on this molecule is the lowest number, because that pKa will react first. And don't tell me about pKa 5, because this is not a carboxylic acid. This has lost its H. It used to be a carboxylic acid, but there's no H there, so don't pretend there's an H there. We've got a bunch of pKa 50s on the CH3 here and the CH here. So they're all sp3 CHs. Don't use the 50s. Use the 17 for the alcohol. pKa 17 or 18, just pick one of those numbers and use it all semester. Whatever the thing you draw over here, you know it's pKb's 14 minus 17, -3. You can save time on tests. You're looking ahead in this course. I don't need to draw everything around up to and including there. I can call it R. Then R is attached to a CH2, which is connected to an O-. If you want to draw the whole thing out, it's fine. But everything I put and called R was up to and including this carbon here. And that's where R is attached to the next carbon. And you can use short forms, which would be really helpful down here, wouldn't it? If we haven't finished with our pKeq, pKeq is always left acid, which was 17, minus the acid on the right, which was 45. And here's where, no calculators, you might mess up. It's -28. If you showed your work and got negative 38 by mistake, I'd still give you a quarter point. If you just wrote the wrong number for pKeq, I can't help you. All right, just verify 17 plus 28 is 45. That works. And KEQ is 10 to the negative of that answer, 10 to the negative power of the previous answer. Nope, there's no P in KEQ. KEQ equals 10 to the negative 28. You can just write 10 to the positive 28. And you thought I forgot, and I did too. But that means big time equilibrium to the right is favored. We have a much more stable acid on the right than we do on the left. And the conjugate bases follow too. This conjugate base is a lot more stable than this conjugate base here. They always go hand in hand. Next one, I'm going to have some kind of a polypeptide.
Doctor?
Yes.
Sorry for interrupting, but for the previous problem, you said we have to look for the lowest pKa on the molecule.
Yep, we have a bunch of CHs that come in at 50. They are to be ignored in any acid that has a pKa less than 50. And 17 reacts. It's 10 to the power of 33 times more acidic than 10 to the 50. If you remember, this is a log scale. So yes, we have to take the strongest acid and react it first. That's just the natures of acids and bases. The strongest ones always react first.
Okay, so why do we disregard the bicarbonate in this case then?
Well, it's not bicarbonate. That's not an H over here. That's a C. So
oh, the C's.
It's well, no, I know your point is still well taken. This is called a carboxylate, which is the conjugate base of a carboxylic acid. The acid's gone already. You can't pretend it's there. It's not. So it's already been deprotonated. You can't deprotonate it again. It's missing its H. Mm-hmm. So it's a very common functional group, the conjugate base of a carboxylic acid, but there's no H there to take off. And we knew from our connection of blue that the acid was this one because it had another H compared to this one, which is missing the H. We know that bases react only with acids, so you're not going to put the H on this molecule here. That'd be a good question, but it's not this question, is it? If this ended up being an acid here, then you would put the H right there. But this is not an acid, it's a base, the conjugate base of this, and the base will take off whatever H is the most acidic here. Are we good?
Yeah, thank you.
All right, you're welcome. And then we're moving down to this one, which has everybody intimidated. You can't know ahead of time what it's going to look like. It's going to be a brand new, some form of an amino acid glued together as a protein or a mini protein. You have enough information here combined with the multiple choice section, which I realize they're not going to be together like this, are they? So I would have to give you more information here. I could do it this way, and I'll show you. And see, I'm thinking ahead about this test myself. I'll show you what it would look like. I'm looking for fall 19, and I know you don't see what I'm doing here. Basically, I'm just going to fall 19. I'm going to go to the multiple choice quest section and steal some information about the same molecule that you don't see here. And I'm still looking. I had it open, but it's closed. Here it comes. We're looking for something that looks like that molecule. And I have found it here. I've got the fully deprotonated form. I'm going to snip it and bring it. And okay. Oh, I'm having one of those days. All my tools moved and I keep clicking where the old tool used to be. There's the fully deprotonated form. This is the triprotonated form. Well, we can get a piece of information from that, can't we? Tri out of 4, which means the only acid missing, if you have 3 protons remaining from something that had 4 to start with, charges are not important. It's the number of H's, right? H4A is that, and that one is the one that's missing. That's how you go from fully protonated to tri. Okay, and look down here and look up here, and let's see, what's the, this is the fully deprotonated, and let's see, we can figure out what H got taken off here because there's only one missing, and I see the only thing we have in common, that's different. This is different, and this is different, and this stayed the same. So that tells us the first H to come off was this one. This is fully deprotonated. This is with only one missing. There's your 3.9. So if that H was there, that would be the 3.9. Right there, where it says ASP. And then the rest of your molecule. So that's what we get from that tip. There's an 8 and it says thiol. You would do yourself a large favor by learning this right now for ahead of time. You see the 3 letters T-H-I in a name. It means sulfur is there. Fact. And it usually means the sulfur took the place of oxygen. So if the THI letters were missing, what would the only 2 letters be left? All, for alcohol. But here is a sulfur version of an alcohol. That's what that says. So you're told pKa2 is right here. pKa2 is right here, thiol. And an sp3 ammonium. Don't pick this one. That's sp2. Okay. And it's an is it an octet violation? No. Wait, are they both at? No, it's sp2. It's got 3 sigmas. Yeah, 3 sigmas and no lone pairs. And this one has 4 sigmas and no lone pairs. So this is the 10.5. And this is the 12.5. Okay, how do you know that was an acid? Well, look, it's missing here. SH is now S minus, and NH3 plus is NH2, and this one stayed the same because it was the only one that was, the only one missing up here. So we haven't even started this question. I'm just doing a little background. What was our strategy from the beginning? And the top of the page was to get rid of spectators, replace the charge. Spectator. Which of those 2 has the extra proton? It's the one on the right. And this is not magic. I didn't invent this number. Where did I get that number from? Here is the data for arsenic acid. You don't have to memorize it. It's right here. There's 3 pKa's. The fully protonated one is this. The diprotonated one is next. And the fully, monoprotonated one is last. And we're going to use the 6.9. We just have to figure out 6.9 lost its H here. And where did it go here? That's the question. We have a species here that's missing an H. It picks up an H from this and becomes this species here. Just think about this reaction backwards. Well, I know the order these things come off. 8 comes off before 10.5 comes off before 12.5. So look at it this way. This is a base. This is an acid. This is an easier way to look at it. This is the base. Which H comes off first? Brings us back to that gentleman's question. We had a 17 up here for the alcohol, and we had a 50 here for the alkane. Which one comes off first? 17. We have an 8, a 10.5, and a 12.5. Which one comes off first? The 8. So we can do ourselves a very, very large favor and try to circle everything except for the CH2SH. This could be very fun, by the way. I'm not a good artist. You know that already. Light pink. Everything up to, but not including the SH. That's not working. You know what I might do? Just to make my life easier. I'm going to get the old scribble brush. Still holds that this is the SH, right? And it just makes this circle a lot easier for me. Everything in that circle up to the CH2 is called R. R goes to CH2, goes to S, and now it has a minus. Why? Because it lost a proton. Where'd the proton go? It went to here. Okay, the only reason I scribbled this off and then redrew it was so I could do a better circle. And guys, ladies and gentlemen, I am going to make sure yours isn't this. This is pretty complicated for the versions of this question. That's probably why the student picked it. Either that or it was fall 19 and just picked that anyway. But yours will be a little more straightforward with all the clues you need right here, because you're not going to see a duplicate of that molecule elsewhere on the exam. All right. We're not finished though. We didn't draw, we drew our box. What's the pKa of the reacting acid? You have to tell me, of all the numbers, there's only one that's going to be important here. And it was the 8. Why the 8 and not the other ones? Well, I didn't use the 3.9 because it was already gone. I didn't use the 10.5 because the 10.5 will not react before an 8. 8's stronger by 10 to the power of 1.5. And for the same reason, I used the 8 before the 12.5. And then we're supposed to calculate pKeq. You take the acid on the left, 8, minus the acid on the right, and you get 1.1 KEQ, 10 to the negative 1.1, and you better circle the arrow that goes away from the smaller number towards the bigger number. The arrow is always like that. Away from the smaller 17 towards the bigger 45. Away from the smaller 6.9 towards the bigger 8.0. And just knowing that, you get a question for circling the correct arrow, which is good. All right. So where are we going to go next? I don't know if I have anything on this next page. Looks pretty blank to me. So that means we are, I may have missed your email if you sent me something that you wanted done. So this is the time for you to speak up, and we'll take a break, but I need somebody to speak up before break with a suggestion of our next problem to do after the break. So feel free. Give me a test and a question number if you got one. Or else we'll have a short review. Not to your advantage having a short review. All right. I'm hearing crickets. We don't like crickets. All right. I will check my email during the break. And I'll come back and at least say goodbye if there's no requests. But you've got 10 minutes. I'll give you 10 full minutes. So if I don't have a request by 12:10, I'm going to come back and say goodbye. All right. So here we go.